Thank you, Jan. Well, good morning, everybody. I'm going to talk about some of the trends in energy. I'm going to first talk about energy, then a little bit about digitalization, and then finally about mobility and what we see going on in the transport area. To give you some context on clean energy, you've probably seen a number of these charts before, but clean energy investment has been growing very rapidly since 2004, which is, I think, just before we started New Energy Finance, through to 2017. And we're now at a third of $1 trillion of net new investment going into the clean energy sector. So that's an appreciable amount of investment. You can see it sort of looks as though it's plateauing a little bit over the last 4 years. I mean, a third of $1 trillion, excuse me, is not to be sneezed at. But if you look at it in terms of capacity, the capacity has still continued to grow. And the reason for that is the cost of clean energy has been coming down, particularly in solar, but also in wind. So we've got this inexorable trend towards lower cost renewables that are now having a real impact on the energy system. And when we started New Energy Finance, it was more a niche part of the energy sector. I think now renewables is absolutely part of the mainstream and causing a lot of disruption in many different directions. In terms of the outlook between now and 2040, these are looking at our capacity projections for the next 25 years or so. And if you look at it today, first of all, we expect the amount of capacity to roughly double globally over that period. And in particular, the mix will change enormously. So today we're talking about roughly 61% is gas, oil or coal generation, so fossil fuel-fired generation. By 2040, it'll be more like 28%. So that's a massive change in terms of the overall installed base. Renewables today is roughly 15% if you add all the components, wind, offshore wind and solar together. And in 2040, it's more like 50%, just under. So again, a huge change. The pink shaded area is just showing flexible capacity and how much of a need there is for things to balance the energy system, and that'll be a theme I'll touch on a few times. So intermittent renewables needs to be supported if it's to have its full effect. Other challenges as energy diversifies, these are a couple of challenges. One is the grid. So if you look in Italy at how many substations are now experiencing reverse power flows, it's roughly 25% for 5% or more of their hours a year. And in terms of decentralization, it's not just the installed capacity. Also, we're seeing decentralization. And this ratio is measuring how much of the investment in the grid or cumulative investment in the grid is at the edge versus the whole investment. So it's a way of thinking about how decentralized is the architecture of the grid and the networks we're looking at today. Again, a very different picture, and we're expecting that to ramp up to rates of 45% or more. So, just a few words on some of the challenges facing utilities. Generators, number of challenges that they're facing, primarily low utilization. Secondly, aging fossil fleet and the need for fuel fleet and the need to maintain that. So we're seeing techniques in digitalization like predictive maintenance starting to come in a big way. The transmission and distribution sectors, similar sort of challenges, but renewable integration is a very important one. And again, balancing intraday frequency, so short-term and longer-term balancing. As we move to a more decentralized network behind the meter generation, and not just generation, but other assets as well, and being able to integrate those assets and integrate the balancing technologies that are needed to make renewables work. And then last but not least, retail. We're seeing customer engagement. Churn, if you're a retailer, is really damaging to the economics of your business. So you want to do everything you can to reduce churn, because it's not just the cost of losing the customer, it's the cost of acquiring the customer back or another customer to replace them. All of that has to be supported by a range of other technologies and approaches, including cybersecurity. So I wanted to talk a little bit about digitalization. It's a word that's much used. And we've seen a a range of technologies in the past that you could describe as digital. Certainly cloud storage. We've seen technologies like batteries, behind-the-meter generation, smart grid. We've been talking about these things for some time now. But it's not just those technologies that are relevant. We're also seeing new technologies starting to appear. Machine learning, for example, is being used a lot in the energy sector, as well as the industrial applications for things like predictive maintenance, things like optimization. Blockchain, possibly much hyped, but some interesting applications there around energy trading and also managing flexible assets as well. I think that's another very interesting one for blockchain. And things like EV charging on a blockchain rather than having a clearinghouse to manage all the transactions between different networks. And then we're seeing things like edge processing. So originally, the thinking was that all of the processing, or most of it, would be done centrally in the cloud. We're finding, or the industry is finding, that a lot of that can actually be done at the edge of the network. So you can have small gateway devices, locally based, that can take decisions based on data very quickly at a relatively low cost. So those are some of the technologies. What is the Internet of Things? That's one very important part of them. Well, we see it in sort of a number of different layers. First of all, you need connected machines to collect the data. Secondly, you can have some of this edge computing that I mentioned earlier. Thirdly, to the extent that it's not processed very locally, you need some network to transmit that data. So we're seeing actually a lot of innovation in that communications layer. You need platforms, and you can think about those a little bit as operating systems to interface with the network, but also interface with the applications and allow people to layer useful applications on top of all this stuff that actually deliver some real value. So predictive maintenance or optimization are just two of those. And then finally, the cybersecurity is very, very important at underpinning all of this. So in terms of innovation, we see in each of those layers startups very active. This is definitely an area where there's huge amounts of innovation. So whether you're talking about platforms, whether you're talking about applications, cybersecurity, specialized hardware, communications, Sigfox, I think, is, if it's not a unicorn, it's probably close to being a unicorn, a European company. So a huge amount of innovation at all those levels, and you can see from the investment numbers a lot of investment flowing in and supporting that. So startups are very active in this new area of digitalization. And not all of these are pure energy, but it definitely affects the energy industry along with some others. One example you may have heard of, just around moving away a little bit from IT, is the technology that Google applied to data center operations. And we looked at this and how they did it. Essentially what they focused on was the energy consumption in data centers that's to do with cooling. In a data center, you want as much energy as possible. Well, you want as little energy as possible, but as much of that as possible going into the computational part of it, rather than cooling the data center. And that's what this power usage effectiveness ratio is. The nearer that is to 1, the better. And you can see they've managed to get that trending down to not quite 1, but much more optimal than it was before. The way they've done that, they've applied deep learning techniques to it. You've got a variety of different states in a data center. It's highly complicated, many different dials you could tweak. You couldn't write a mathematical algorithm to solve this deterministically. So machine learning is a very good technique for doing that and finding a more optimal solution. It may not be the perfect mathematical solution, but it'll be a lot better than the one you had before, as these numbers demonstrate. So we see those kind of analytic techniques starting to be brought in at the software layer increasingly. And some of the benefits of digitalization, this is just one example from NL. I picked NL out because we didn't have time to cover every single utility. There are probably a number of utilities in the audience today, so this is just one example. But they've been applying machine learning in generation, things like thermal imagery, cloud computing, IoT pilots. Distribution, they've been doing smart meters for some time, but are now moving into areas like digital twins, machine learning, and LoRa is one of these communications networks for long-distance wireless, but at a much lower cost than, say, 5G. Energy management, demand response, they bought Enenoc. Dynamic EV charging bought Metroworks. So they're doing a lot around that area, including asset aggregation and things like battery storage management. So again, a lot of these are software and technology-based activities. And then finally, in the retail business, a lot around the connected home and automated customer journey and engagement. NLX, which is kind of their transformation vehicle, and I wouldn't say all of this is due to digitalization, but it's an important component. You can see the numbers. They've achieved significant savings in O&M, lower grid costs, and are anticipating revenues from things like smart home platforms through to 2020. So this is just one example of a company. And by the way, in Europe, we see much more of this innovation than we do in other parts of the world, including the US. I think Europe is definitely in the lead on a lot of this. So in the final section, I wanted to talk about mobility and particularly about EVs. So at BNEF, we love doing data. We love tracking things. It's kind of our heritage. This is just showing the information we've been able to get by benchmarking a wide range of buyers and sellers in the lithium-ion market. And you can see just how far the prices have fallen. They've fallen from $1,000 per kilowatt hour in 2010 down to about $200 per kilowatt hour today. So a 5-fold reduction in lithium-ion battery prices. And if you project it forward in terms of the learning rate, a learning rate, you can think about it as every time the cumulative volume of something doubles, how much does the price fall or the cost fall? And for lithium-ion, it's about 19 to 20% is the learning rate. That takes you down, if you project forwards, to just over $70 per kilowatt hour by the late 2020s, which interestingly is the point, in fact, before the late 2020s, more like the mid-2020s, an EV will be the same cost when you go out and buy it as an internal combustion engine vehicle. It's cheaper to run after that, but the sticker price could be very similar in terms of the cost structure that goes into it. And that could be one thing that causes the EVs to lift off. So in our long-range projections through to 2040, we're projecting that by 2040 you'll see adoption rates as high as 60%, actually 70%, as a percentage of new vehicle sales in Europe. I think that's sort of, it's harder to forecast because it's way out into the future. But I think the really interesting thing is where does the lift-off point occur on the pathway to that? And I would definitely watch the point at which things start to become price indifferent. One example of that, and why I might say that, is Norway. In Norway, you have a lot of taxation for vehicles, which makes it almost as cheap to buy an EV as it does any other vehicle, because everything gets taxed except EVs get taxed a lot less. So they've reached that point of price indifference much earlier than other markets. And you can see what's happened. I mean, this is exponential growth in Norway. So they've gone from 1% to 3% to 5% to 6%, very quickly to 23%, 39%, and it's probably even higher. I'm sure it's north of 40% today. These were the numbers by the end of 2017. So a really fast adoption curve in Norway. Probably a lot of other reasons that this has happened, but I think it's a very interesting indication of how fast this industry can develop when that sort of thing happens. The final thing I just wanted to say is on autonomous vehicles. We're expecting that to happen rather later, but there's a huge number of pilots going on around the world. So if you thought this was just about Silicon Valley, I mean, there is a lot of experimentation and innovation going on there, but it's also occurring in Europe, a huge amount actually in China. If you want to look at what's happening to the EV market, do look at China, because I think they've made that a strategic priority, just as they made solar and other things a strategic priority. So I think we can expect a lot to happen there. And when we get to autonomous vehicles, plus lower cost, plus more sharing, I haven't talked about that, but more, we're seeing that with Uber. We could see a very, very different transport system. So all those things are they're all intertwined and interlinked. So that's basically what I wanted to cover. Hopefully that's given you a sense of what's going on in the sector broadly and a little bit of what's happening in transport. Thank you.